So we have the worldwide flood, which is intimately connected as far as the topography of the Earth is concerned with the post-worldwide flood, the post-flood period. And we have the end of the Ice Age. The evidence of the Ice Age points to a recent catastrophic worldwide flood. So then people would say, okay, what happens at the end of the Ice Age? A sudden warming of the climate. These things, when examined carefully, don't happen. Very slowly. At the end of an Ice Age, which we've looked at for a while here, there's a sudden warming of the climate. And what does that do? Well, here's what it does. Geophysical and paleontological evidence indicate that the glacial age ended rather suddenly. Both the evidence of foraminiferal types, different species inhabit cold waters and warm waters. And did you know that? Different species inhabit cold waters and warm waters. That's obvious. And oxygen isotope composition in the carbonate of their shells, the ratios of these isotopes is also dependent upon water temperature, and they unite in indicating a somewhat sharp change from glacial to temperate conditions. Cesar Emiliani, Ancient Temperatures, Scientific American. Underline that. Marvelous publications this man, this engineer, resorts to support evidence either way from a scientific frame of reference. The data indicate a rather sudden change from more or less stable glacial conditions to post-glacial conditions. D.B. Erickson, Brooker, Culp, Woolen. The late Pleistocene, these words don't roll off my tongue. The late Pleistocene climates and deep sea sediments. Science magazine. Other lines of evidence, such as sudden change from deposition of sand to silt in the Mississippi Delta and a rapid desiccation of pluvial lakes, all dated more or less simultaneously, point to the same conclusion. Richard J. Russell. He's an authority on the Mississippi Basin geology and recent president of the Geological Society of America. This guy selects his articles. Make a good point from both sides of the issue. In summary, shoreline irregularity and alluvial filling of valleys indicate a recent general rise of sea level. Comparatively small areas of deltas and topographic instability along coasts, which is evidenced by rapid advance of delta fronts and anomalous features such as Sapatica Lake, suggests that the rise in sea level has been rapid. Worldwide flood. Richard J. Russell, instability of sea levels, American scientist. Still more recently, geologists from Columbia's Lamont Geological Laboratories have noted the recency, geologically speaking, of this sudden warming of the Earth's temperatures. From the evidence listed above, it is clear that a major fluctuation in climate occurred close to 11,000 years ago. That's their estimate. Wow. The primary observation that both surface ocean temperatures and deep sea sedimentation rates were abruptly altered at this time. Not uniformitarianism, is it? That is supplemented by evidence from more local systems. The level of the Great Basin lakes fell from the highest terraces to a position close to that observed at present. The silt and clay load of the Mississippi River was suddenly retained in the alluvial valley and delta. A rapid ice retreat opened the northern drainage systems of the Great Lakes, and terrestrial temperatures rose to nearly interglacial levels in Europe. In each case, they're assuming multiple glaciers here. In each case, the transition is the most obvious features of the entire record. Wallace, Brooker, Ewing, and Heisen. Evidence for an abrupt change in climate close to 11,000 years ago. Of course, that was the end of the worldwide flood, right? We've only got about 2,000 years from Adam and Eve to Abraham, and Abraham throughout the Isaac, Jacob, Jewish age, short of 2,000 by 7, and then when Jesus ascended, somewhere around 20 A.D., we got pretty close to 2,000 years now that it's 2022. It is obvious from our previous discussion of the radiocarbon dating assumptions that the 11,000-year date must be too high. So these worldwide events clearly date from about the time of the flood and its after effects. Neither was this warming of the Earth a gradual process occupying thousands or millions of years. And this comes out of the mouth of geologists and evolutionists. Evidence from a number of geographically isolated systems suggests that the warming which occurred at the close of Wisconsin glacial times was extremely abrupt. It seems there must have been a rather abrupt warming of the climate in order for the glaciers to melt and the oceanic temperature to change as rapidly as the evidence indicates. This last glacier that they're looking at was the only glacier. This again argues for some explanation outside the scope of doctrinaire uniformitarianism. The flood events, and particularly the associated atmospheric changes, can once again suggest a cause adequate to explain this event. Most of the incident solar energy is contained in the visible radiation which can penetrate right through the atmosphere. The Earth re-emits the energy it receives from the sun. Go fix that. From the sun. So let me repeat. Most of the incident solar energy is contained in the visible radiation which can penetrate right through the atmosphere. It doesn't have a frozen, super frozen ice canopy above the Earth now to protect it. That's where the worldwide flood came from above, and then the subterranean canyons below, or containers below. The Earth re-emits the energy it receives from the sun, but being a much cooler body, it does so mainly in the infrared region of the spectrum. Infrared radiation is strongly absorbed by water vapor, carbon dioxide, and ozone. These constituents, therefore, act like the glass of a greenhouse. They trap the outgoing energy. The effect is of the utmost importance, for without it, the mean surface temperature would be lower by almost 40 degrees centigrade, and life could not exist. Sorry about that. The T went off, too. Most of the incident solar energy is contained on the Earth at this time, is contained in the visible radiation which can penetrate right through the atmosphere. The Earth re-emits the energy it receives from the sun. But, being a much cooler body, it does so mainly in the infrared region of the spectrum. Infrared radiation is strongly absorbed by water, vapor, carbon dioxide, and ozone. These constituents, therefore, act like the glass of a greenhouse. They trap the outgoing energy. The effect is of the utmost importance, for without it, the mean surface temperature would be lower by almost 40 degrees centigrade, and life could not exist. Any life. So, D.R. Bates, I shouldn't say any life, there's some exceptions. D.R. Bates, composition and structure of the atmosphere and the Earth and its atmosphere. These three constituents, water vapor, ozone, and carbon dioxide, must have been present in large amounts in the antediluvian atmosphere. The first water vapor we have already discussed in connection with the inferred canopy, the ice canopy. The waters above the firmament. Ozone would have been formed by the reaction of the sun's ultraviolet radiation with molecules of oxygen and of water vapor as at present. However, the equilibrium amount of ozone in the atmosphere depends upon the temperature of the atmosphere, so that the location of the antediluvian ozonosphere may have been different from the present. The amount of carbon dioxide in the atmosphere is a function of the amount of carbon-producing and carbon-extracting mechanisms on the Earth's surface. Through the process of photosynthesis, carbon dioxide is taken out of the air and used in plant growth, then returned to the air through through the processes of expiration, decay, excreta, burning, and so on. Also, the waters of the ocean exchange carbon dioxide with the atmosphere, the amount increasing as the surface temperature increases. The formation of carbonates in rocks and shells, as well as their weathering out and return to the atmosphere, also enter the cyclic balance. The amount in the antediluvian atmosphere must have been very high in order to maintain equilibrium with the large amounts of plant life, the large amount of continental relative to oceanic areas, and the large amount of carbonate fixing organisms in the seas. The effect of this large carbon dioxide and ozone concentration in the pre-flood antediluvian atmosphere augmented the effect of the canopy in maintaining the global greenhouse effect and in shielding the Earth from harmful radiation, ultraviolet radiation, short-wavelength radiation coming from the sun in outer space. Everybody had a wonderful set of organisms, life on Earth, much larger, greater concentration of oxygen held in, maybe 30% greater, by that canopy, super frozen, yet letting the sunlight through without the ultraviolet radiation blocked by the super frozen hydrogen water, H2O. Hydrogen would be more metallic, more like a metal. With the flood, these balances were all profoundly modified. The vast areas of plants were buried, and their carbon content was concentrated in coal seams. Extensive bodies of organic materials were converted into petroleum hydrocarbons. The deluge precipitated the atmospheric ozone and carbon dioxide in all probability along with the canopy, which was destroyed by volcanic activity going up in the atmosphere, breaking up the ice. The ice comes down to a warmer air temperature. It was super frozen way up there, and it melted. It instantly became 40 days and 40 nights of rain, temporarily partially denuding the atmosphere of these constituents. So the deluge precipitated the atmospheric ozone and carbon dioxide in all probability, along with the canopy, the water, temporarily, partially denuding the atmosphere of these constituents. Quick stuff happens quickly. So now, post-flood and post the one-time, only-time glacier is a post-time after that. Abundant carbon dioxide produced plant growth and a rise in temperature, ending the Ice Age. That's how it ended. The lowering of the atmospheric temperature after the flood as a result of these atmospheric changes, especially in higher latitudes, certainly supplies a potent mechanism for initiating glaciation of continental magnitudes. Worldwide, all of a sudden, boom, because the situation was there throughout the whole planet. The carbon dioxide remaining in the air would support only a limited plant life as compared with the luxuriant pre-flood stands and their only limited animal life as well. However, in time, there is no doubt but that the shielding effect of the firmament canopy, the ice canopy, would have been at least in part restored by the formation of the following. Ozonosphere would have been soon formed in essentially its present character once the new hydrologic cycle was established and more or less stabilized. More important, as plants and animals began to grow again and gradually to multiply, their life processes would gradually restore carbon dioxide to the atmosphere, approaching the balance that has in general characterized present times. Along with this carbon dioxide equilibrium between ocean and atmosphere required gradual discharge of the gas from the ocean into the air. Further, volcanic sources undoubtedly yielded a certain amount to the atmosphere, which we have historical record of recently, and all of this in turn would have caused a gradual rise in terrestrial temperatures, probably at an accelerating rate. We worry about global warming. One might think from the destruction of plant and animal life on the Earth's surface by the deluge would likewise have enriched the air with CO2 rather than reduced it through burning and decomposition. Remember that. It's still there, burning and decomposition. However, most of the organic matter